Today we'll be talking about metallic bonding continuation. So what are exactly are metallic bonding? Metallic bondings involves metal atoms, and these metal atoms they tend to be held very strongly to each other by metallic bonds to form a giant lattice structure. In the metal lattice, these metal atoms will actually lose their outer electrons and become positively charged ions. As the outer electrons are no longer bounded onto any metal atoms, they tend to be delocalized, meaning they can actually move everywhere they can be, and that these outer electrons move freely between metal ions like a cloud of negative charge. That is why a metallic bond is this force of attraction between the positive metal ions and the sea of mobile electrons. So when it comes to physical properties of the metals, right, these metals they actually are very good conductors of electricity, and that the outer electrons are actually able to move freely within the metal lattice structure. Mobile electrons, on the other hand, because they are mobile and delocalized, they are also able to carry these charges, and hence able to conduct electricity along the metal. That is why for metals they tend to be good conductors of electricity. They are also good conductors of heat, as the movement of the mobile electrons within them also allows heat energy to be transferred over easily and fast. As metals are solid, they tend to be also tightly packed together with very little space between them. Hence, within a very small unit of volume, you will see that there is actually a lot of all these atoms that are combined or packed together, resulting in a high density. Now, in terms of high melting and boiling point, similarly, they are held by very strong electrostatic forces of attraction between the positively charged metallic ions with the negative charged electron cloud. A large amount of energy is also needed to overcome these metallic bonds. Next, these metals they tend to be malleable, meaning they can be hammered into different shapes, and they are also ductile, which can be drawn into wires without actually breaking them. So they actually, what happens is like spaghetti, when you pull the flour, or the noodles, right? They tend to actually be able to retain in shapes. That's the meaning of ductile. So when I pull the metals, they don't actually break into different parts. Malleable is basically when you actually bend or hammer it, they still stay in shape in some way without breaking. So for physical properties, before a force is applied, these metal atoms tend to form an orderly and rigid arrangement. So when a force is applied, one layer of metal ions slide over the other through the sea of electrons. And the metallic bonding is also not disrupted. So in a nutshell, the physical properties of metal, they are good conductor of electricity, they have good conductors of heat, they have high density, high melting points, boiling point, malleable and ductile. So generally in MCQ, we will see that these are some of the physical properties of metal. They may actually go in deeper to ask you why are they good conductors of electricity and heat, or maybe even to high melting and boiling point. But other than that, generally these are all you have to know for metals. Okay, so that's all for this chapter. Thank you.